because today we will learn about the graphical analysis. Some day ago, a question was asked that why we are learning such matrices, arrays, lists, and data types in R. Because to conduct a research, first you have to learn the language fundamentals. Now we will come to a research. What we do in research? In research, we collect data, we process data, and we find some patterns. We try to find some relationship between these patterns and variables. We establish relationship. So first thing to find the relationship between the variables is to watch the graphical representation or visualization of data. Now, how we visualize the data in R with various different aspects. Let's see that. Here, today we will start our interesting topic, and that is graphical analysis. In R, the plot function allows you to create a plot passing two vectors of the same length. Remember this, the vector should be of same length or a data frame, a matrix, or even other objects, depending on its class or the input type. So with the help of plot function, what we can achieve, we'll see here in this program. First thing, we can plot a point. Very basic thing that we can plot is a point with the help of plot function. To point any data onto the paper or onto the computer screen, we need its coordinate. That means x axis and the y axis. So here we can see there is a plot function where I have provided two variables 1 and 3. There are two values actually. One is for x and 3 is for y. And when you do this command on our console, you will get this output. So let's go to our R console. One more thing I want to tell you that whenever you use R console, it takes some time to start because it is very heavy program. It loads all and required necessary components. So it takes some time. So I have opened my R console and I'm showing it to you. So here is our R console where we'll provide the commands. I'll make this in such a manner that you will be able to see the graphs properly. Here, I will write the command plot. You can see it is giving me the help. First thing is x, that is 1 I am giving here, and another y value is 3. And I will press enter. And you can see in the corresponding plot window, here it is, you will see the name of this window is plot window, where it plots a point between 1 and 3. On the y, it is 3. On the x, it is 1. It is the just basic plot. How R uses plot function. This is just the demonstration of that. So we can plot the points in that manner. What if you want to plot simultaneous points? Then you can also use plot slice operator 1 is to say 10. So plot 1 to 10 and you will find this result that there is a line, straight line from 1 to 10. These are very basic commands, but the plot function is very useful and it creates a enormous details and graphics. So basics are necessary. Now I'm telling you another plot scenario. Suppose you want to plot between two vectors. Here I already created some vectors. I will paste them and you know how to create vectors in R. So I'm just putting here like this. You can see I'm writing here 1, comma 2, comma 3, comma 4, comma 5. Here are the vector values 1, 2, 3, 4, 5 are the x axis, and on y axis we can take some random values. See, this is leftward in direction. C is for creating the variable vector, and after that suppose I want to print like that. Remember this, I have taken random data to show you. So in this, I have created x values as a vector and y values as another vector, right? Now, I will use plot function with x, comma, y. That means on x-axis, x values are there. On y-axis, y values are there. And I will use plot function. You can see it shows me what my data is representing on the graph. So this is just basic of the plot function. Now, let me show you some more examples. Here, now suppose you want to plot a line. These were all about points. Now you want to plot a line on the graph. Then here it is. Plot this and type should be L. So let me show you it on the R console. What we'll do, we'll write like that. There is the plot command. For example, plot 1 to 10, type equals, and in single inverted comma, you should write L. We want a line from the plot. Here you can see in the adjacent window, you will find the graph of line. Now, what if I want to plot the vectors in the line format? So for this, I will use plot x, comma y, comma type equals, in single inverted comma, use L. Here you can see that the values are joined with line. So it is a type of line graph. You can prepare line in that manner. Now I'm showing you it is not about all the things in the plot. We will discuss those arguments in the plot function that makes it richer. Please pay attention to all these. In a plot function, we can use type that tells R how to plot the supplied coordinates. For example, as standalone points or joined by lines or both dot and lines. So this type will tell. For example, in the previous demonstration, I have used type equal to L. L means line plot. P means point plot, which is by default. Then call. Call stands for colors. To use for plotting points and lines, you can give colors to the lines and points. PCH stand for point character. What type of character you want to use in the plot function? For example, in normal, it plots a circle as a point, but you can change them in plus, in triangle, or there are so many characters we will discuss later on. Then CEX stands for character expansion. This controls the size of plotted point characters. If you want to increase the size of the point, you can use CEX command in plot. LTY stands for line type. This specifies the type of line to use to connect the points. For example, you want to use solid line, dotted line, or a dashed line. We'll see them later on in this class. LWT, that stands for line width. This controls the thickness of plotted lines. You can increase the line width. XLim and YLim. This provides the limits for horizontal range and vertical range. This is the scale or limit of the range where you can provide the values and it will be plotted between that range only. Then main, XLab, YLab. Options to include plot title, the horizontal axis label and the vertical axis label respectively. So here it is a simple demonstration that we will use one by one. I have taken output because in case of some emergency, we can show you the output. Now we will execute all such things on our R console. So let's go to our R console. I will request you that you should practice on R console all these commands simultaneously. Let's say plot from 1, we will use x comma y. There are two vectors we have already cleared it. Then we will use color equal to, and in inverted commas you can provide the names of that color, and in this R Studio it will show you the color by putting the text background in that color. For example, I have selected green here. I have typed green. It will showing me that output will be in this color. If color is not available, then you can't use. So I'm using this, and you can see that I have given plot X, Y, color should be green. It is plotting the points in green color. Now, suppose I want to draw a line in a blue color, then X and Y, type equals L. I'm using this command in between to show that I want to print a line with, I'm changing the color here, say red. So you can see it is showing me The red color will be of this type in our console. In the adjacent plot window, you can see the output is in red color, a red line between X and Y, segments of different intersections that you can see because X and Y are not in continuous line. You can see the graph is of line type and color is red. Now, another thing that we want to change PCH, that is point type. So, what is that? That PCH is stand for point character. So it will change. Suppose I am using 2, PCH2, then and color will be blue, COL blue. You can say it is showing me that color will be the same that much. Now you can see instead of circles, it is printed the triangles. Similarly, you can try other options. For example, 4 up to 25 special symbols are there in the plot. So you can use different type of plot characters. Now, if you want to change the size of the plot character, then how to increase that size? For example, plot X and Y. I'm changing the size to 3. No color will be given. You can see the circles and point size has been increased to 3 times of the normal size. Okay. So this is the use of CEX. Now we'll use more arguments into the plot. Here I am showing you the different types with the presentation first, and then we will use them. Here you can see the type 0 is blank, that is a line type. You can use 1 for solid line, 2 for dashed line, 3 for dotted line, 4 for dot dash line, and 5 for long dash line, and 6 for two dash line. These are the types of lines. LTY, line type. This argument will be supplied and output will be as given in this table. So from 0 to 6, you can provide the arguments. Let's do that on our console. We are using plot command between X and Y, which I have already created. Now, type should be L so that we can select the line type. The plot type is L, and line type we can also specify with LTI. So LTY will give the different type of lines depending on what type you are using. Here I have given 1. So you can see it is the normal line. Now I'll use 2. Then you can see it is giving me the dash line. I'm using the LTY as a 3. You can see it is giving me the smaller dashes. Then 4, you can see dash dot structure. And 5, you can see large dash. And last one that we are using LTY 6. This is small dash, larger dash. So this is all about type L and LTY, line type. Now, what different type of plots we can use? I'm showing you first on the screen, then we will practice them on our console. Here, you can see the different types of plot. That means type L stands for line plot. Type P is a default, which is points plot. Type B, both points and line. Type O, both over plotted. Type A, stairs plot. Type H, histogram like plot. N is stand for no plotting. So we will don't use the no plotting argument. We just use PLBOSH. PL Bosch. You can remember with this. So let's see what happens in case of type L. It will just print a straight line. In case of stairs, it will print in form of stairs. In case of P, which is by default, it is only points. In case of overlapping, it will print both lines and dot with overlapping pattern. That's why O. B stands for both. That means plots with points and middle bit by the lines. Type H, that means it's a histogram type plot. So let's do with our data. So what to write here? Plot function for x comma y, and we just use type argument. We have already seen what is the meaning of L. Now I am plotting with argument B. Here you can see both the things are there. That means points are plotted and their middles are plotted by lines. But what if you want a continuous plot? Then we will use O, overlap pattern. That means like this. So it is the overlap pattern you can see. This time I am using the same command with staircase pattern. Yeah, these are the staircases. And one more is histogram pattern. This is a kind of histogram. So this is all about the different types of plot with plot function. The next topic, we use font argument to change the axis font style. Let's do that. I'm using plot function and I'm giving font equal to 2. It will change the font style, you can see. Similarly, some other font, it has been changed to italics. In the adjacent window, you can see. Yeah, the fonts has been changed 2 times. So what kind of font you want to use, you just practice whatever fonts are there inside your R system, you can use them. Now, what about the labels and titles in the plot? Can we provide the labels to axis and name to the chart also? Yes. The command is plot x comma y. Suppose I want to name, first I will provide the type should be overlapped. This is the argument. And color is red, should be in inverted commas. Then after that, I want to make the title of this chart. For that, I will use main argument of the plot. The main argument plot of, I'm using x and y. You can use plot of teachers and students, whatever data you are having. So if I press enter, you can see the chart title has been changed to plot x and y. Now what if I want to change the name of axis? For that, we can use the command xlab. Xlabel for x axis. I'm using that. These are the x values. I'm using this as a x label. Similarly, ylab for y values. This time you can see in the my plot function, it has returned the graph with plot x and y, which is the main chart title. I have used this. Then xlab, x values, here x values, and y label means y axis label should be y values, which is here. So this is about various arguments of plot functions. Let's proceed further. Points function. Suppose you want to insert points between a plotted line. I want to say you have already plotted a chart and you want to add some points to that chart, not on the new chart. Then we can use points function. I'm showing you the text of that function so that you can note it down. And after that, we will use that function. Here, it is the description of points function. It is used to add a group of points of specified shapes, size, and color to an existing plot. Remember this. What is the syntax? Syntax means the method of use. You have to provide points, then x, y, cex means size of the point, pch the style of the point, and then color. If you don't provide other arguments, it will just plot x and y. So xy should be vector of coordinates, cx size of points, pch shape of points, color means color of points. Here I have already taken some another example. Let's execute that example on our console. X values and then y values. I have given two commands over here, x and y. So there are two vectors I have created with this x, another one is y. I will plot a new chart with these values. Here you can see the plot of this function. I will change the type. Here you can see it is overlapping like this. Now on this plot, I want to print some more dots. So I can use point function to plot extra points in this already plotted graph. Let's do that. I will create two more vectors with extra points to show you. Here I have created x2 and y2. The two values because x and y we are already using. So I'll press enter. It will create two vector values with x2 and y2. Now remember the point function, how to use that inside the plot. Points, you have to plot points. The name of function is points. Here, points x2 and y2 with size 2. Here I have taken sixth variant of the style so that it would be different and colors will be blue. Here you can see in the format of triangles, other points has been added to my already plotted graph. So this is about the point function. With this point function, you can plot the, here I can also change the style that you can see PCH equal to 4, color equal to blue. The same, at the same area you can find the crosses are there. So if you have plotted graph and you want to add points, you can use points function in R. Now, what about if you want to plot a line In the plot, let's do that. We use abline function. Here it is. Abline, or you can say AB line function. It is used to add one or more straight lines to the graph. The syntax is abline A equals to null, B equals to null, H equal to nulls, and B equals to null. Here, A and B are the intercepts, and H and V are the horizontal and vertical values. A and B, it specifies the intercept and slope of the line. H specify the Y value on horizontal line. We specify X values on the vertical lines. Now, what it will return? It will plot a straight line into the given plot area. Here already I have done this. So let's do that on our R console. Now use plot command to plot CARE's data set. It is the inbuilt data set inside the R. R provides a lot of already recorded observations for our practical purposes. So I'm using CARE's data. CARE's data, first I'll show you what is inside CARE's data. It contains speed and distance. Here it is. Let me show you. Speed and distance traveled by cars. So this data set has to be plotted with normal plot. So I'll just use only plot and cars. It will give me this output. Now I want to add line. So if you remember, to add line, we use abline function. If you want to add vertical line, then you can use V equals to and the value on the vertical axis. That means we'll provide X value over here. So suppose I want to use vertical line from 18 with color green. Here you can see in the adjacent graph, it has plotted a line with value 18. You can clearly see a vertical line with value 18 and color is green. Now, suppose I want to add horizontal line, then I will use abline. I will use horizontal argument. The value of the horizontal axis, I'm giving here 45. I'm using the color, this time red, for the horizontal line. You can see at 45, it is plotted a red line on the graph. So points function add points to the plotted area, which I've already made. And abline function plots straight lines with given horizontal or vertical value to the graph. Now let's proceed further. The next topic is pie charts. We use pie function to print pie chart in R. A pie chart is a circular statistical graphic which is divided into slices to illustrate numerical proportions. So it's a circular statistical graphic. We already have seen pie chart when in some poll they ask question and how many of them say yes, how many of them say no, how many are unable to answer. These are shown with the circular graph with the values. So we can create pie chart with pie function, and this pie function takes following things. X, this parameter is a vector that contains the numeric values which are used in the pie chart. There should be X variable that must contain numeric values and labels. This parameter gives the description to the slices in the pie chart. Radius. This parameter is used to indicate the radius of the circle of the pie chart, value between -1 and +1. Then main. This parameter represents title of the pie chart. As in the plot function, we have used main, that means the main title of the chart. Then clockwise, whether you have to print the chart in a clockwise manner or anti-clockwise manner. So this parameter contains the logical value that indicates whether the slices are drawn clockwise or in anti-clockwise direction. Then COL, color. This parameter gives color to the pie in the graph. So let's do some practical. Here I have taken a vector projects with values 23, 56, 20 and 63. They are number of projects in Mumbai, Pune, Chennai and Bangalore. So in Mumbai, there are 23 projects are there. In Pune, there are 56 projects. In Chennai, 20 projects are there. And Bangalore, 63 projects are there. So I will use these vectors directly into the R console to create the pie chart to show you. Here, I have given the values like that. Projects with values of vectors 23, 56, 20 and 63. These are the number values which will create a vector project. Then labels with vector string vectors Mumbai, Pune, Chennai and Bangalore. There will be two vectors created and here it is. So I will check project. Yeah, it is there with these values. Then I will check labels. Yes. You can see projects and labels, the two values has been created. Now I will use pie function to print what I want to use projects, comma. Now I must tell what are the labels of these projects. Okay, so labels are with the names labels. I've created with the city names. In the adjacent screen, you can see the pie chart with the given values. We can also change the color.
Sir,
How to? Yes.
sir, good evening. Sir,
Good
can't
evening.
we give 23 number after Mumbai within brackets? Can we add numerical that the number of projects 23 after Mumbai
Yes.
in the pie chart?
Uh, yes. For example, if you want to give that labels, you have to write that values with labels field. We can also use labels like that. For example, you want to see labels with the values, then you can use the values as projects, project with projects. You can see this. So only one value you can use to print. So with project and label as projects, that means it will show you that 23 is having 23 value, but since the pie itself shows the how much portion it is taking, so we need not to specify the values, we have to specify the names of that area where that portion is being used. So we use this command labels, so it will show me that Mumbai is taking that much area, Pune is taking that much area, and Chennai, it is the visualized representation of 23, 56, 20, and 63. That's what the pie chart is. So that was very nice question. uh, we can, if you want to print, then you can use that thing into labels. That means you can use Mumbai. After that Mumbai, you can use 23 inside that. For example, here in Mumbai, when I was creating, I can place 23 so that it will be displayed over there. Any other doubt?
Thank you.
Most welcome. So what about if you want to change the colors of labels, because these are the default colors which is not that much appealing. If you want to change the colors, then how to do that? There is also an option in pie chart. We can provide titles and colors in the pie chart. Let me show you how. Here I have already created a program. Here you can see we have created these two values, that means projects and labels. And now I want to change the rainbow colors. So how to do that? Let's do. I want to change the label city pie chart, city and project pie chart. I have only written city here. I will use project also as a word, and then color in the rainbow color palette. So how to do that? Let's do this into our R console. This time, again, I'm using the same command, but I will change some things inside the brackets. I will provide the main title. That means this is city versus project pie chart. And I want to add colors to it. The color should be rainbow color palette. So you have to How many colors you want to use? We have to provide that. We have studied length function. Color equals rainbow. And how many colors it should provide? There should be length argument with labels. Or I should use projects. Same thing will happen, but it is more convenient. Yeah, the rainbow color palette works like this. The rainbow color palette will give you the 4 different colors from rainbow color segment, and it will give the heading also city project chart. Color is rainbow with the length of projects. How many colors will be there? It will be provided by the length argument of projects. If 10 projects will be there, then it will select 10 rainbow colors to print that chart. So this is how we can change the colors. Now we'll come to bar charts. This is the first step in the research, that we must find some relationship by looking at the charts. So what are bar charts? You already know bar chart shows you the pictorial representation of data that represent categorical data with rectangular bars with heights or lengths proportional to the values that they represent. That means bar chart is simply rectangular bars either in vertical or horizontal direction. Syntax is bar plot. H means the data. X label, Y label. You know that value names for X axis and Y axis. Main means name of the chart. Names dot argument. That means what you want to provide on the X axis. Then color. Let me again show you the parameters. H, this parameter is a vector or matrix containing numeric values which are used in bar chart. X lab, this parameter is the label for X axis in the bar chart. Y lab, this parameter is the label for Y axis in the bar chart. Main, this parameter is the title of the bar chart. Names.arg, this parameter is a vector of names appearing under each bar in bar chart. Then call, this parameter is used to give colors to the bars in the graph. Here is an example. Suppose we have data values like this in a vector. Then we will plot the bar plot with the data, X label, Y label, main title, and color is optional. So let's do it on our R console. Here is our R console. Let me see if X and Y. Yes, we already have X here. Suppose I want to plot the data of X. So what I have to do? What was the function? Bar plot. Remember, bar plot here with X. I am giving only one thing. That is, I just want a bar plot of X. Here it is. You can see. We have one negative value. That's why it is giving me this output. Bar plot X2. You can see it also possesses some negative value. That's why it is giving me that output. Now let me create some vector which contains only positive values so that we can understand x, c, then 10, 20, 45, 34, 22, 47, 87, 21, 20. Again, here is a set of random values for x. Now I'm using the bar plot function on this. You can see here a systematic representation of bars. But we are not finding the names. So
Main is title is missing.
yes, so that's what I want to tell you, that everything we can write here. You can write x lab equals x values, then y lab, that means y title, should be given with y values. Suppose if this is height of the person, or if this is age, we can write here age also. Okay, so suppose if this is all about age, so we can use age. So x value, y value. Then I want to give the chart title name age. This time we can find the x value corresponding age and main title is age is printed. Now what about names argument? Suppose we have names of all these values, then we can print that names with names dot arg. Suppose these values are to be taken in the names, so we can use names arg as x. That means you can see the argument of the ages has been printed with the corresponding values. Since here when I expand, you can see it takes that much values. If I reduce, it will reduce to some less values because I have zoomed due to recording. Now, what about if you want to print in horizontal direction? Bar plot can be either in vertical direction or in horizontal direction. So how to print that? Let's do that. We will use HORIZ here in the last HORIZ horizontal equals to either true or false. So I am putting here true. Now you can see that it is printing in the horizontal direction. So bar plot creates bar charts. We can also use colors over here. This time I am not using horizontal argument, I am giving color. Here it is. So you can see the bars has been drawn in red colors. Similarly, suppose for horizontal you want to draw in blue color, So you can provide color argument blue. This is how we print bar charts. Now we should move to our next topic. And what is that? Let me show you. Label, title, and color in bar chart. Suppose these are the values, and these are the values for corresponding Jan, Feb, March, April, May, June. It may be the temperature, it may be some other value for the months. So, and if I want to plot bar chart with these labels, so how we can do that? So what you have to do, first create a vector with values, another vector with names of that labels. We have already created values, we can put names for those. Since it would take long time, I'll just use what is inside the presentation. That means I'll create a vector with name A with these values. I'm showing you in the R console. Here, I have created a variable A. You can use a small a also. Let me do that. For demonstration purpose, I have taken this A. Using this command, I will create a variable named A. Here you can see. Similarly, I can create a B variable with the names Jan, Feb, March, April, May, June. So let's do Jan, comma, Feb, then comma, one for March, APR for April, then May, and last one is for JUN for June. I've created B vector with this. Let's see. Yes. Now I'll create a bar plot. That means a bar chart with A, the main values. Then I'll give some titles. What are X on this bar chart? Months. So since month name should be there, so I'm typing here months. Then Y lab should be say temperature. Taking random names dot arg should be B. That means I'm taking January, February, March, April, May, June as a vector into the names argument, and I'm using color equal to green. This time it will create a bar chart in that manner. Since I have zoomed too much to show you, so I will increase this and I'll show you that it will print like that. Here the temperature is there, and Jan, Feb, March, April, May, June, these are the months. One more thing I want to add, and that is main title. Suppose I want to add main title in that, then I will use the main argument here. First, I have to use comma, and then the main equals what should be the title? Month versus temperature. This time you will see in this graph, you will find the main title is what we have given, month versus temperature. Here are the months and corresponding temperatures are in the form of bar chart. I hope this time it is clear. So you have to use the arguments in the function to provide or expand your chart. Now we'll come to another chart type, histograms. To create histograms, we use HIST function. Hist function is used to create histogram. A histogram represents the frequencies of values of a variable bucketed into ranges. Each bar in histogram represents the height of the member of values present in that range. As you are from background of research, you already know what are histograms. How we create histograms in R. We'll use hist function. We'll provide V, that means set of values, then main title, then label of X, then X limb, Y limb, breaks, color, and border. These are the arguments that we can use with our hist function. What are these? V is the vector containing numeric values used in histogram. Main indicate the title of the chart. Col is used to set colors of the bars. Border is used to set border color of each bar. Xlab is used to give description of x-axis. X limit is used to specify the range of values on the x-axis. Y lim is used to specify the range of values on y-axis. Breaks. It is used to mention the width of each bar. There are so many options are there, but we'll use the frequent one so that we just want to visualize the data. Here, I have taken a vector with, with these values and I have created histogram. In histogram, I have given the data, label, then color, then border. Here it is. We already have data of temperature in our R console. So we will create histogram of that. Or we can use some more values of X. Let's do that in our R console. As you know, histogram count the frequency. So let's create a vector with some frequencies of the values. Let here I have given these values. You can see and variable x. So this is the data in my x. You can see 10, 12, 34, 67, 45, 45, 67 again, 34, 23, 12, 10, 10, 10, 89. Can we print the histogram? Yes, with hist function. And then I am just supplying only x to show you the what the raw output of this function. Here you can see histogram of x. Here it is the frequency of the values. Here is the complete range. So in between 0 to 20, there are 6 values. In between 20 to 40, there are 3 values, and so on. Can we count this? Uh, First, we have to use some decoration over here, that what we are using. So we'll use the graphical arguments of the histogram functions. We'll provide some values to here. We'll provide color and border. So this is the histogram of X with color blue and border red. Here is the output. This time you can see this histogram has been generated with the borders red and color blue. Now, if you want to count the frequencies of the elements, then you can use like this. M is equal to histogram of X. Instead of typing, I am using just M equals to in front of this. Hope you can understand. Yes. So if I print M, it will give me so many information that we'll use later on. First thing, it will give me the counts. Breaks are 0 to 20, 20 to 40, 40 to 60, and 60 to 80, and 80 to 100 in the intervals of 20, and it will count them as follows: 6, 3, 2, 2, 1. So this is how we can check the count and breaks in our histogram.
Sir,
Yes.
I think the execution of the program is very nice. The class is very nice, but such a long syntax with the double inverted commas is equal to. We
Yes.
need to practice a lot. I think.
Yes, that's why I was asking you at that time that the basics of R should be completed. And practice makes men perfect. If we are recording this session, and it will be live on the YouTube for forever on RFI channel, so you can go there and you can watch and take the rest of the things from that. So, but still, I want to say that here it is just starting of the R. It is just starting of the R for research purpose. So we are coming to that. Now you can input the data into R. What you have learned till now, you can input the data into R. You can import the data from various file formats into R, and that data you can print onto the console. You can use that data for graphical purposes. Up to that we have reached. From tomorrow onwards, what we will do the statistical analysis. That means we will do the descriptive statistics on these data. Okay. So The data is very important in research, and how to maintain that data we have learned till now. And visualization of that data has been given in today's class. And one more thing, one more plot that I want to show you. As you know, what is the box plot is, I'll show. Here, box plot. Now, what is a box plot function? It is type of a chart that depicts a group of numerical data through their quartiles. Now, this word quartile you must know before plotting the bar plot, sorry, box plot. So a box plot gives a 5 number summary of set of data, which is what is the minimum. It is the minimum value in the data set excluding the outliers. There are outliers in the data. Whenever you collect, whenever you input into the R, there will be outliers. We will take that much data which is in our range. Then first quartile Q1, 25% of data lies below the first or lower quartile. Median, that is Q2, quartile 2 is also called median. It is the midpoint of the data set. Half of the values lie below it and half above of it. Third quartile, that is Q3, 75% of the data lies below the third, or that is upper quartile. And then maximum, it is the maximum value in the data set excluding the outliers. You can see this is how we print the box plot. Here is the minimum, then whisker, then quartile 1, which is the starting of 25%, then median in middle of the box plot, then 25% after upper quartile. This upper quartile is up to 75% data. It lies up to 75% data. Then after that, 25%, it completes the data. And from Q1 to Q3, you already know it is known as interquartile range. So this is about the box plot, but how we can draw box plot in R. For this, the syntax is box plot. X means the data, then data, the data frame of that data, notch, variable widths, names, and main. And what these are, let's discuss them. X is the vector or a formula for which you want to plot the box plot. Data is the data frame from which you want to extract the data. Notch is the logical value set as true to draw a notch. There will be a notch in the data, means a point will be drawn. So we'll leave it. Where width is the logical value set as true to draw width of the box proportionate to the sample size. You have taken the sample size and you want that box plot should be of the same size, then you can use where width equal to true. Names are the group labels which will be printed under each box plot, and main is used to give a title to the graph. There are so many things, but in research, what we take generally main things, we'll discuss that. There is a data for box plot. We'll create the data once again. I've already created this. Yeah, instead of typing, I have already put enter over here. Now my X data contains that much values. There may be some repeating values. I can also create histogram of that to see what kind of data it is. So here you can see it can give me the histogram of X. I can find out the frequencies. There's some of data is between from 0 to 20 having maximum frequency, and secondary from 60 to 80 interval. I am also having another frequency, maximum frequency. and second middle one from 40 to 60, I also having some frequency. It is not the normal distribution of data. We can also find the normal distribution by the use of histogram. We'll learn more about this in another session. But now what we want to do, we want to plot a box plot. So we just use box plot, the second one of X. It's just raw plot. So now it is giving me just basic information that median is between, you can see on your system you will be having some more details because of zoom I am having less detail. So box plot shows me this output. What if I want to color this output, or I want to change the title? You must know the names can be given, main title can be given, or data frame can be used. So one more thing that we can use in the box plot, I'll show you. There is already a cars data. I'm showing you that data to be here. You can see the speed and distance, the box plot of the speed and distance data. So if there are data sets, you can use them into box plot to find the quartiles, mean, median, sorry, median and quartile one, Q1 and third quartile, and you can find the visualization of interquartile range. You can, for your practice, you can use cars data. For example, I have given you that plot and cars. When you install R, this cars data is automatically get installed into your computer system. You can use this. This is the basic plot. You can call it the scatter plot because the scattering of the data has been shown, and normal plot is there. If you want to join them by lines, you can just use type and L, and what the output will be, you can see like this. This is the line type chart. If you want both, then you can use overlapping of this. Here it is. And you can use color in the inverted comma. Remember to put names in small and inverted comma. Here it is. Now you want to put main title, then main, it is the cars data. So main title will be the cars. One by one, we are doing each and everything that we have learned on cars data. So this is uh, speed and distance are already the labels because we have already supplied the cars data frame, which contains the column values, names of the column values, that means speed and distance. And now I'm giving the main title is cars. You can also use cars, speed and distance for more detail. For example, cars with speed and distance. So this will be printed as a main title. Now you can see cars with speed and distance. So this is how I printed the chart with the plot function. Now I want to print a point in the same graph. So I have given you points function. Then value of X and Y you have to provide. Suppose on X I want 10 and on Y I want 80, so that it would be visible. And I want the color to be red. No, different color. I will use blue color. Now you can see that from 10 to 80, there is a blue dot to show me that what I want to focus. Similarly, I can use line function in this plot, and I want a vertical line at 15 and horizontal line at 50, 15 and 50. So I will use V vertical line 8 value 15, the middle of the data set with color green. Here you can see I have plotted a line on the same data set. Now I am using again for horizontal with color yellow. This time you can see it has given me line on same value, that is on 15 value. I want to use at 50 value and color should be black, dark black. So here we have used plot function, points function, line function, and we can provide the labels. Similarly, we have used pie function. We can use pie chart. Of pie chart is generally used where lower values are there. Generally on the scale, yes, no, not available from 1 to 5. If I will create a pie chart of that type of value, uh, for example, X, that contains so many options, then it is not a feasible thing to understand. So use pie chart only for ranks, the values that you can easily count. The when output is outcomes are very less. So it will show you the basic percentage or fraction of that value from a complete whole pie. Similarly, we have used histogram. Let me print histogram of x2. This was my x2. Similarly, histogram of x. This is the histogram of x. It will give me the frequencies. And one more thing that we have learned, that was box plot. So for today, this is the end of our class. Any queries?
No, sir.
No, sir.
Whenever you exit from R console, I will suggest that you should save your environment. So tomorrow at 6 p.m. we will learn about discrete statistics.